We are in chapter 8, polynomials. So we're going to split this chapter into two sections. The first section is simplifying, combining them, and the second is breaking them apart or factoring. Today we're going to focus on adding and subtracting polynomials. So we're just combining like terms. A polynomial, poly means many, is a monomial, one term, or a son of monomials, okay, that creates the term polynomial. A blank is the sum of two monomials. A binomial, bi means two, and a trinomial is three. So one term, two terms are separated between pluses and minuses, three terms. A blank of a monomial is the sum of the exponents of all its variables. The blank of a polynomial is the greatest degree. Okay, I don't like this. I just want to say the highest degree. We don't really do this. Okay, so I'm going to cross this out. I don't like it. The degree of the polynomial is what we're just going to write here. So you look to the highest degree. So here, its highest degree is 1. You look here, its highest degree is 2. Here, it's 2. Okay. Example 1, determine whether each expression is a polynomial. If it is, find the degree and then write whether it's a monomial, binomial, or trinomial. So a polynomial is never going to really have division where the variable is in the exponent or in the denominator. So yes, it is. The degree, there isn't one, so no degree. And it's one term, so it's a monomial. I have two terms. The degree is C. I'm not a fan of this. But degree is C. And then, I don't like that. Let's make this degree like 5. And then there are two terms, so it's a binomial. The highest degree here is 2. And it is a monomial. There are 3 terms here, so it's a trinomial. Your highest degree is 4. This is a binomial, okay? We're not going to have multiple letters and multiple degrees in the math that we are using, so let's just focus on n. Your highest degree is 3. You're a binomial. And here, you are not a polynomial. Not because 3 is in the denominator, because p is in the denominator. That's not going to happen. Okay, polynomials are usually written in standard form. Standard form just means highest degree to lowest degree. So for instance, if we have this here, the highest degree is x squared, the next highest degree is 3x, and then just a constant with no degree. It says identify the leading coefficient. Well, 5 would be the leading coefficient, the number before the variable. Okay, I want you to pause the video. I want you to try these 3. Leading coefficient here, -5. That's called the leading. We forgot to fill that in. Coefficient. Here, leading coefficient, -3. Here, leading coefficient is just a negative, so -1. Okay. Example 3 asks us to find the sum. Okay, the sum is just adding. We can just drop the parentheses because nothing is affecting adding. So we have a 6p and a 2p, which is an 8p. We have a 3 and a 7, which is a 10. We have a -2a cubed and an 8a cubed, which is a positive 6a cubed. And then we have a 9 and a -11, which is a -2. We have a 1z squared and a 3z squared, which is a 4z squared. I have a -12 and a -1, which is a -13z. And I have a 7 and I have a -4, which is a 3. Here, our highest degree, we just pretty much say that x squared y, And that can't go with x squared. It has to be a 1x squared y, a negative 2. So a 1 and a negative 2 is a negative 1x squared y. Here, we'll go with x next because it's alphabetical. We just have a negative 3x squared, no other next x squareds. And then here we have a y and a 3y, which is a 1y and a 3y. So we have a 4y. All right, so that's adding. Now we're dealing with subtraction, which seems to always be harder because you can subtract a polynomial by adding its additive inverse. To find the additive inverse of a polynomial, write the opposite of each term. So what that means is nothing's happening to this first quantity. So we just write it as 19m plus 7. Rewrite these, please. We're subtracting 5m. We're subtracting 2. That's what they mean when it's finding its inverse. The inverse of 2 that's positive is a negative 2, okay? So now we just combine like terms like we did on the front, okay? So we have 19 and negative 5, which is a positive 14. 7 and negative 2, which is a positive 5. That's it. So you're doing the same thing. What you could do is just distribute the negative throughout all of them and then clean them up. It's up to you. That's how my brain works. If you just want to do them one at a time, that's fine too. Pause the video and then watch me go through it all. Okay, so I just took the time because I had the same flow going. I just did it all at once. I'm subtracting each term. So if it's negative, it's now positive. If it's negative, negative, it's going to be positive. Now let's combine like terms. I have a 9v5, I have a negative 5, so now I have a 4v to the 5th. I have negative 12 and a negative 16, so it's negative 28. Here, I have a 1c to the 4th and a negative 5c to the 4th, so it's negative 4c to the 4th. I have an 8c squared. I have a 3c. I have a negative 7 and a negative 12, so I have a negative 19. If you want to try pausing and doing these and then watching mine, go for it. It should be a 10w cubed, a 14w, a 15w. That's going to be a negative 1w plus 7. Negative 6p squared. Oh, we have an NP. Are there any other NPs? Nope. This order is kind of tricky. So if you don't have the same order I do, that's fine. But you should have the combining like terms that I do. So I just see a high degree, so I'm going with that one. I guess you could go in alphabetical order first, so I'd go with an R. Negative 8r squared x. Is there another r squared x? No. If you're like, whoa, I'm overwhelmed, well, then just start from the beginning. We have a 4rx. We have a rx squared. That's not the same thing. We have an rxt. There's no other rx's. So like I said, I'm not going to be picky with the order on this one. Then we have our x squareds. Sure, let's go with that. There's none other. And this is our xt. So we're going with that. We're going with that. Then we have an x squared and an x squared, which is 1x squared and a 1x squared, so it's 2x squared. Okay, you're not going to run into this much. All right, and lastly, the sides of a triangle are shown on the diagram. Write the expression for the triangle's perimeter. Well, when you find the perimeter, it's this side plus this side plus this side. So you're just combining like terms. So this is what you're doing. Why they write parentheses is you're saying, oh, I'm taking this and adding it to this. Nothing really happens in the parentheses. So we got a 2x, a 3x, 4x. Okay, 5, 9. 3 minus 1 is 2, 4. The end. Find the value of x if this is supposed to be 40. So if this is supposed to be 40, then what is x going to be? Divide by 9 is 4. Explain how you got this value. Set 9x plus equals 40, since 40 is perimeter and 9x plus 4 is perimeter. And last one, it says the triangle shown below has a perimeter of 11x plus 5. All right, so the perimeter is 11x plus 5. Write an expression that can be used to find the dimension of the third side. All right, well, so far we have a 4x minus 3 and a 5x minus 7. So this is equal to 4x plus 3 plus 5x minus 7 plus the third side. Okay. Well, if I combine like terms, 9x minus 4 plus the third side. Oops. Well, if I remove 9x from the other side, I have 2x plus 5 equals negative 4 plus the third side. If I add 4 to both sides, then I have a 2x plus 9 equals third side. And that's what we go here. Okay. If you have any questions, don't hesitate.